So we've been working on exponential functions for a few days now, and we're about to start looking specifically at situations. But I want to kind of recap what we've covered so far just so that we know what we need to know for our lesson today. So first of all, the kind of parent function or the basic equation for an exponential function is y equals a times b to the x. And it may look like this, like a times b to the x, or it may have a parentheses b to the x. If a is 1, then you might not even, they might just not put it there, so you might have b to the x or b to the x. So if a is 1, it may not be written, because it's an invisible, okay? Now, as we've talked about before, a has to be greater than 0, b has to be greater than 0, because if a isn't greater than 0, we have nothing to grow, and if b isn't bigger than 0, then we're not growing. So, or decaying, well, nothing's happening. So if a is not bigger than 0, we got nothing to grow. If b isn't bigger than 0, then nothing's happening. So it has to be, these values have to be bigger than 0. Okay, so when we look more closely at this equation, just so you know, y equals a times b to the x. A is the start value or your y-intercept. So if you're looking at a table, you're looking for the row that starts with, the one that starts with 0. If you're looking at a graph, you're looking for where it crosses the y-axis. B is your growth rate if it's greater than 1 or between, it has to be, if it's growth if it's greater than 1, it's decay rate if it's between 0 and 1. Now, the x, we haven't really kind of specified this, but the x is the number of intervals. So we've done a lot of examples where we talked about folding paper. So like in this case, x would be number of folds. But when we're talking about things that happen over time, so like let's say that I have bacteria that are splitting every hour, then 1 hour would be the interval. And let's say they said we had how many bacteria would you have after a day? Well, if the number of intervals is in hours, then I have to look at that in terms of hours, which would be 24. So this tells me how many times I grow or decay. So and that depends on what the problem tells me. Okay? And remember, for all of these problems, our domain is all real numbers. Now again, this is just with a function, not with a situation. And our range is y is greater than the asymptote. Usually that's 0, so usually it's y is greater than 0. But it is possible that they will show you a graph that has an or talk about a situation where the asymptote is where it's approaching some other number. Whatever number it's approaching is y is greater than that number for the range. If they don't tell you, then it's probably 0, because 99 times out of 100 it is. Okay, so let's get off these green notes that you picked up, and let's talk about how we would use these problems. Now, I noticed when you guys took your benchmark that there was not a lot of highlighter action going. Everybody wanted to be part of the highlighter party on reading day, but nobody had time for a highlighter on algebra test day. So let's talk about this. I'm going to actually highlight the things that I think are important. It says a banking account starts with $10. This is the worst highlighter to use, but whatever. Every month, the money every month, so I'm going to say every month, the money is tripled. Okay? Now, right now, every month doesn't matter. But when I'm looking at a word problem, it might, because if they tell me how much money will she have after 3 years, so let's say they say 3 years. Well, that equals 36 months. So I'm going to, oh my gosh, seriously, like, I need to find this bank and put my money in this account because I need my money to triple. But let's say they say after 3 hours how much money is she going to have? Ridiculous money. That's how much. Okay. But I would put that. I wouldn't put my exponent wouldn't be 3 in that case. It would be 36 because it's counting by month. Okay. So my initial value, what I start with is 10. Okay. My base or multiplier. So what I'm multiplying it by is 3, because tripled means 3. So my equation is a times b to the x, which is 10 times 3 to the x. Or you can put 10 parentheses 3 to the x, just like that. Is it growing or decaying? How can I tell? There's not enough time for pauses here, but how I can tell is that if this is bigger than 1, so if b is greater than 1, I have growth. If b is between 0 and 1, I have decay. Well, since b is greater than 1, I have growth. Okay? We're going to pause for a second. I want you guys to try this one. There are 20,000 owls in the wild. Every decade, the number of owls is halved. We're going to take maybe a minute. I'm going to pause it and give you time to find A, B, and the equation and whether it's growth or decay. Okay, so I'm going to take my trusty highlighter and I'm going to highlight the things that matter. There are 20,000 owls in the wild. So I'm going to assume that I'm starting with 20,000 owls. Now, this does not mean that the 20,000 owls is all we ever had. It means that when I start observing in this problem, 20,000 owls is what I've got. So I start with 20,000 owls, okay? It says every decade, the number of owls is halved, okay? So that tells me that I'm starting, as I observe, I start with these 20,000 owls. And they're being halved every decade. So the equation is 20,000 times 1/2 to the x. Now, why did I put that half in parentheses? Does anybody know? It doesn't matter, when I put the half in parentheses, it doesn't matter if I put it like this. It doesn't matter if I make a fraction. So if I use the alpha y equals button and make a fraction, it's not that big of a deal. But let's say I put it in the calculator like this. 20,000 times 1/2 to the x. According to order of operations, what is it going to do first? It's going to do exponents first, which means it's going to do this before it does this. It's going to do them 1, 2, 3. So if I don't put this in parentheses, it's not going to raise the 2. It's not going to raise half to the x power. It's going to raise 2 to the x power. Now again, if you're using the alpha y equals button and putting it in your calculator, that doesn't matter. So like what I mean is, let me just show you what this looks like. So if I do 20,000 times 1/2, let's say to the 4th, I get 1250. If I do 20,000 times 1/2 to the 4th, oh, I get the same answer. Oh, okay, well, never mind. I don't need to worry about that. Okay, I was wrong this time. Go me. I guess that does make sense. Okay, let me show you another example. Okay, let me show you when it matters. Okay, I figured it out. Okay, let's say instead of 1/2, we say it's decreasing by 2/3. Okay, now let's try this again. 2/3. I don't get the same answer now. So when it's 1, when 1 is my numerator, it doesn't really make that much of a difference. But if I have anything that's not 1 something, then I'm going to have a problem. Okay, so anyway, all that to say, just humor me and oh wow, that is so much better. Humor me and put it in your calculator in parentheses. If you're just humor me. Okay, if you're not using alpha y equals, put it in parentheses. That was a whole long conversation about that. We got decay. Okay. Now, what is the thing that you need to pay the most attention to here when you're actually looking at this situation, when they ask you a question? What you have to pay attention to is the interval. So that means whatever goes in this x here is my interval. So if they tell me how many owls will we have at the end of the century? Okay, let's say century. How many decades are there in a century? There are 10 decades in a century. So that would be 20,000 times 1/2 to the 10. Not 100. There's 100 years in a century, but I'm counting by the decade. Does this make sense? This is why the interval matters. That's why this part right here, the interval, why you have to pay attention to it. Okay? Let's look at the last one. I want you guys to try this one. Okay, as a reward, you ask for a penny the first day and to double the amount of pennies every day for 30 days. Okay, so you ask for a penny the first day and double for 30 days. Each day for 30 days. Okay, so when we're done with this, we're going to figure out how many pennies you got. So what is my initial value? I start off with a penny. And I am doubling those pennies. So I have 1 times, well, y equals 1 times 2 to the x, or just y equals 2 to the x. Okay? I'm growing my money. Now, for this problem, what is my interval? My interval is each day for 30 days. So if I want to find out how much money I'm going to have at the end of 30 days, what would I substitute in for x? I'd substitute in 30, because 30 is my number of intervals. So I would do y equals 2 to the 30. And let's see how much we have. Y equals 2 to the 30. That many pennies. That's a lot of pennies. If we divide by 100, that tells us we're going to have $10,737,418.24. Is that crazy? That is a ton of money. Okay, exponential growth is fabulous. Like, seriously, I got to find this person who's going to give the penny and double them. Then I got to find this person with his bank account. I'm not so concerned about the owls, but I'm all about the money. Okay, so we're going to practice this some. We're going to practice both types of things. Your homework is going to be practice on that. We're going to do some practice in class on some other stuff. But remember, situations are different. And we'll start talking about domain of the situations as well. But with a situation, we really have to pay attention to the interval. We have to pay attention to the to what's happening to it and what we start with.